Hello. In this video, we are going to begin investigating even and odd functions. So, how do we determine if a function is even? What does that even mean? It means that our graph is going to be symmetric to the y-axis. So let's look at an example. We have a parabola. It has the same thing on both sides of the y-axis. If this was on a piece of paper and we took our piece of paper and we folded it hot dog style, we would have the same thing on both sides. It's mirrored across the y-axis. So that's when you have an even function. What about when we have odd functions? They're symmetric with respect to the origin. So let's look at an example. Here we have a cubic function. Our origin is 0, 0, right? Okay. Now, what makes this odd? It's much harder to fold these depending on where your function's at, so it's harder to visualize. But we can see here that we have the same thing in quadrant 1 that we have in quadrant 3. We also have the same thing in quadrant 2 that we have in quadrant 4, which is nothing. So that's how this function is odd, and that's what it means to be symmetric with respect to the origin. Now, how can we determine if, algebraically, if functions are even, odd, or neither? Graphs can be neither as well. So even, odd, or neither. So we can test a function. If we have a function, everywhere we see an x, we replace it with a negative x and simplify. For a function to be even, once we simplify, we're going to get the same thing as our original function. Same signs, everything. For odd, we're going to get the exact opposite. So if something was positive, it's now negative. If something else was negative, it's now positive. And lastly, for it to be neither means it doesn't fit either one of these cases. But we're going to see what this means in a more concrete example. So let's begin with example 1. We're going to determine if the function is even, odd, or neither. We're starting with f of x equals x to the 4th minus 2x squared plus 1. So to begin, we need to plug in negative x. See, this is where those evaluating functions comes into play. Negative x. So we have negative x to the 4th minus 2 times negative x squared plus 1. Negative x to the 4th, any number raised to the 4th power is always going to be positive. So we know that's a positive x to the 4th. And then we have negative x squared. Any number raised to the even power is going to be positive. So we know it's negative 2x squared. And then we have to bring down our plus 1. We want to compare this line 3 with line 1. What we notice is on both lines we have positive x to the 4th. On both lines we have negative 2x squared, and on both lines we have positive 1. These lines are the exact same. Exact. Not almost, but the exact. So we have an even function. Maybe that method didn't make much sense to you, so I'm going to show you another method. Instead of plugging in negative x, we can plug in 1 and negative 1 and compare our results. So let's plug in 1 to our original function. F of 1, 1 to the 4th minus 2 times 1 squared plus 1 is going to equal 0. Now we need to also plug in negative 1. Negative 1 to the 4th minus 2 times negative 1 squared plus 1 is going to equal 0. Now guys, if you're at home and you're using your calculator, that is awesome. But remember, we must put negative numbers in parentheses. Because if you would not have put negative 1 in parentheses, raising it to the 4th power or raising it to the 2nd power, you would have gotten an answer other than 0, and that would not have led you to the correct answer for the question on determining if the function is even, odd, or neither. I don't know, I have a question mark after that, because that's a statement. Anyway, beside the point. We compare 0 and 0 are the same exact thing. Therefore, the function is even. So we saw either way, using negative x or using 1 and negative 1, that we determined the function was even. Same thing, we're going to determine if the function is even, odd, or neither, but we have a different function, 2x cubed plus 5x. So we're going to plug in a negative x. Negative x to the 3rd power. Anytime that we're raising a negative number to any number to the 3rd power, it's going to keep its sign. So if we're raising a negative number to the 3rd power, it's going to stay negative. So we have negative 2x cubed. And negative x to the 1st power, that's an odd power, so it's going to stay negative, so we have negative 5x. So we need to compare the 3rd line with the 1st line. We have a 2x cubed and a negative 2x cubed, so that's opposite. And then we have a 5x and a negative 5x, that's opposite. Therefore, this function is odd. But let's try our other method and see if it works as well. We're going to plug in 1 and negative 1, remember? Okay, when we plug in 1, 2 times 1 cubed plus 5 times 1 is going to give us 7. When we plug in negative 1, 2 times negative 1 cubed plus 5 times the negative 1 is going to give us negative 7. 7 and negative 7 are opposites of one another. Therefore, we still agree that this function is odd. All right, lastly, we have one more example. I bet you can already guess what kind of function it's going to be, but let's just go ahead and look at it just in case. So we have f of x equals x squared plus 2x minus 1. So we need to plug in negative x. So negative x squared is going to be positive x. 2 times negative x is going to be negative 2x, and then we're going to bring down our negative 1. Once again, we need to compare this with the original function. So we have an x squared in the original and an x squared in the new. So maybe this is even. We have a positive 2x in the original and a negative 2x in the new function. And we have a negative 1 and a negative 1. So this was an even and an odd mixed all together. So that means it is, you were right, it's neither. But let's test our other method just to make sure it works. We have 1 squared plus 2 times 1 minus 1, which is 2. And then we have negative 1 squared plus 2 times negative 1 minus 1, which is negative 3. 2 and negative 3 have absolutely no relation to one another. So we know that this is going to be neither. That concludes our video on even, odd, even and odd functions. And we also learned about functions that are neither. I'll see you all next time.